Right, now this is the graph of cosec x, right? You will see this in the page 50 also, right? Page 50 also. So just a little bit of explanation why it's coming. We know now if you take sine pi over 2 is 1, and again sine pi is 0, sine 3 pi over 2 is minus 1, sine 2 pi is 0, again sine 5 pi over 2 is 1. So actually sine graph goes like this. That also I will draw here, right, where you can see also roughly, right? So sine graph goes like this, like this, 0, and from here, okay, I hope I drew it correct, right? So again he will go like this. I think there's a small 1, sorry, 1 and 0. So 1 and 0, again 1 and 0, again 1 and 0, like that. So you will notice, right, when sine x is 1, always cosec x also 1. That property is there, right? But when the sine x is reaching 0, right, reaching 0, right, y value reaching 0, the 1 over sine x, right? So actually cosec x is equal to 1 over sine x. So when this quantity reaches 0, 1 over division 0 becomes a big value, so he goes to minus infinity. Right, now here also from the negative side it becomes 0. Because of that cosec x goes to negative infinity. So this is the graph, right, you will get for cosec x, right? So, and in this case actually it is shifted. Earlier this graph for sec x, it was here. Actually pi over 2 we have shifted to the right side or left side, right? Now the trouble for that is, right, now we have to exclude these points, whichever. Now in this dotted line here, this cosec x will reach 0, so 2 pi you can't have. So because of that, x can take any real, and 2, I mean here n pi, if it is pi or 2 pi or 3 pi, cosec x is not defined. Cosec x is not defined. So we can say here x, and x does not belong to n pi, and we can say n can have a negative value, n, right, here n in negative value, and n is an integer, right? So all the n pi's, right, n pi's are excluded from the real line, right, and that would be the domain. And what would be the range? It is same as the sec x. The reason was the graph was shifted to right or left. Actually it was not changed, so the projection to the y-axis is the same. So that would be x is, or you can say y, right, whatever, x, such that, right, x is greater than or equal to 1. It can have also 1, and it will from minus 1 also it can, if it is lesser than minus 1, you can't have any value, right? So the range would be this, right? So I will erase this part and I will draw the cortex, right, cortex, and we will see how the graph will look like, and then I will explain. You all can look at that graph on the page 50 also while I am explaining. Right, so here cortex or cot theta will look like this, but we will consider this our tan theta normal graph. So we know tan 0 is 0, and when it's reaching pi over 2, right, it goes minus infinity. These things actually I explained in detail, right, when we were doing that all STC, right, and why it is happening like this. We are taking the heights of this x coordinate, y coordinate, those things, and these graphs were well explained in detail, right? So you have to revise if you can't remember, right? So right now anyway we know it's like this. So here when it's going to minus pi over 2 also, it reaches minus infinity. So this is the shape. Now we will see now cot x, right, or cot theta equal to 1 over tan theta, right? 1 over tan theta, 1 over tan theta, 1 over tan theta, right? So 1 over. So here what should happen is when this line is reaching 0, negative also reaching 0, right, and negative value, 1 over tan theta should be negative and increasing, I mean the magnitude wise. So it is right. So when it is reaching 0, he goes to minus infinity, like that. So that part is okay, right? And also when tan theta is reaching a very high value, very high value means magnitude wise, minus negative, right? Then 1 over tan theta, that means 1 over, it becomes infinity, minus infinity. So this becomes very large when it's going here. Cot theta, this is cot theta, 1 over tan, this is tan theta. Cot theta will reach 0. This is reaching 0. So that's also all right. Here reaching 0, right? And so when our tan theta goes like this, right, cot theta actually in two parts, like this and like this. So remember, this is like you have to reach the 0 like this and then turn, and here gradient always but never touches, right? So remember that. So same, now if you consider this portion, it is same as this in tan theta, like that. So this graph will be repetitive, right? Same thing will come, but here from here. So this one, so what we should remember is in cot theta, 0 we can't actually, from the domain we can't have 0, we can't have pi, right? And we can't have 2 pi because those are not defined. And again so the range will not have that, but other than all reals will have, right? So if we shade it like this, we should have a, I mean kind of this is the domain. But what would be the range, right? What would be the range? Actually all the values are there in reals. When you project it, right, when you project it to the y-axis, all the reals are there. So the range will be actually reals, and but the domain would be I mean 2 pi, pi, 3 pi over 2, right? So multiples of pi over 2, right? If you put an integer here, those things should be taken off, right? So this graph is there in page 50 also, and the explanation is there. Please go through that also. Now I will put a summary for all three graphs, I mean the domains and the range, and then we'll see to do the example, right? Okay. Right, so finally domain, right? Domain and range we will discuss. Sec x will have actually this form, x such that x belong to reals and x does not belong to this type of multiples where n belong to z. So minus any integer, minus whole number, 0 and 1 2 3 4. So other than those, x can take any real number. And our famous thing, x is greater than or equal to 1 or less than or equal to minus. So remember this. Another thing, this is or. If you put and, it is wrong, right? And it comes for the cosec x also, same range. And domain is a little different. Here it becomes n pi, right? And n is belong to z. And also cot theta, we discuss all the values are there in the range, right? In the range. While I'm explaining, you can look at the page 50 and 51, right? Page this is there in page 50 and page 51. Sorry, you can't see it. Page 50 and 51, right? 51. Okay. Right, so here also x does not belong to n pi, and n is a whole number where it can have minus 2, minus 1, minus 100, 0, 1 2 3 4, like that. So those values should not be there in the domain, otherwise because in those values it's reaching infinite value, right? Because of that, there here also in these excluded values, the graph is reaching infinity. Here also it's like that, right? In the range it's like that. So this is the summary. You all can go through that. Now I will do the example, actually one of the example now, yeah, in page 49, example 3 I will do, and then you can see how to approach questions like this, right? Page 49, right? Now it is I mean page 49, example 3 I will do. They are asking us to sketch sec theta in this range only, right? In this range only. So what would, I mean, that's the only, I mean, there's no part, only one, right? Here like this, right? So the most important thing is here we can have minus 90 and minus 180, right? Here plus 90 and 180, and theta can take any value than that, but we are considering this. So now sec theta, right? Sec theta is equal to 1 over cos theta, right? If you remember, you can draw that to get the help, right, from the cos theta. To get the help from the cos theta, what we should do is, now I will take here in this region, actually cos 0 is 1, cos 0 is 1, 90 is this one. So actually he oscillates, right? The cos theta oscillates in this, between these two bands, right? Cos theta. So here we can say minus 1, this is 1, right? I'll put it in black color. So cos theta goes like this, right? Like this he goes, and then again he reaches, I mean, I will put a solid line later, we will, I mean, okay, like this he goes and continues like this, and again he comes like this, right? And in 90 he reaches 0, not reaches, exactly goes for 0, right? 90 like this, and then in this one 180 he goes for minus 1. So this is the shape of, right, cos x. This is the shape of cos x, and I have not drawn the other part because we are considering only this. And if you want know, he will go like this, our, right? It's like a sine curve, right? It's shifted. So now the idea is, now again this is again explanation, right? So if now this should be taken for help, right? And if you consider these critical boundaries of x, right, critical boundaries of x, right, here, right? So now we have to sketch, so sketch 1 over cos theta, so whatever the value, so here cos theta is 1 here in this place, cos theta is 1 divided by 1. So our graph also, the new graph sec theta will go from here. But when the graph is reaching 90, right, I mean this x is reaching 90, the graph value will reach 0. So here sec theta will reach, when he is going from here, 1 over 0, cos theta is becoming 0. So the sec theta should go for infinity, so the shape should go like this, but he never should touch this. And the same way, now this is minus value and it's going to minus 0. I mean minus 0 means little, if you take a little bit to this side, it will be a minus 1, minus very small value. So 1 over minus small value is a big negative value, right? Okay, so yeah, sorry, it's not minus, positive. Although the theta is negative, the cos theta is positive. So here it will be like this, right, like this. And so now we will see in this part, right? So here now we drew like this. Here actually again from infinity right? Now if you take this part from now we'll come to this, right? It is -1, so -1 sec theta also, so here 1 divided by -1 also -1, then sec theta should be, so sec theta graph, this red graph should go from here. And also when he is reaching the cos theta is a negative value. Now if you take 90 plus some small thing, cos theta is a very small negative value, so 1 over very small is huge negative value, that is sec theta. So he comes like this, and actually he should continue this way. I will not draw. Okay, so actually these things you have to think and draw. Don't try to memorize, right? And same thing happens here. So if it is 0, negative fellow, and this is -1, both are actually crossing from the same place, and here he will go like this. So the shape, actually what we are considering is the red graph, right? So you can actually, this one you can erase it, right? But in this one it has shown, because this example, so we can say we say red graph, right, is equivalent to y is equal to sec theta. So that's all for the example 3. Now we will we'll see whether we drew the most important values here. One we have shown, actually this 0 I have not shown, that should be there, theta is there, and here we have to put sec theta. Sec theta should be there, and the critical boundaries I have put. Now this is a sketch, but these things should be there at least up to here, right? Okay, so this is reaching infinity also I have shown. I think it's okay, it is all right, but the only trouble now, because this is the first example we are doing in this chapter, we have shown the both fellows, right? But in the exam, don't do it, better erase it after this. If you really find it difficult, draw the cos theta, and then from that, if you are going to take the sec theta, after drawing the sec theta, erase it off, right? Now we'll go to the example 4. Right, in page 51 we have example 4, right? So they are asking us to sketch 4 cosec x, right? 4 cosec x, and in the range of this. So surely we have to take the help of sin x first. This multiplication, actually it's a transformation, right? So sin x I will draw in a side, right? Sin x goes like this, okay, like this, right here. So it is here 0, and here pi over 2, and here pi, and again here pi over 2, right? So now pi over 2, pi here, pi, right, pi, like that. So now we will draw the cosec x first, right? Cosec x, what would happen is, because it is going into 0, right, like this, right, in this range he will stay like this here, and also here 1 and 0. So if you take like this, he will turn like, so this p will get reflected and it will get stretched, right? So another thing, and also here in 1, right, like this it will be. And what should happen is, so cosec x now, red color you can see, but multiplication by 4 graph, right? Now please remember, these also the transformation. I know, when I'm telling many things, these are the areas, like some students they can't remember. So always, now multiplying by 4, it should stretch, all the y coordinates should multiplied by 4. Now we are thinking of this red graph, so this 1 will jump to 4 and it will get stretched, so it will get reached. So the graph should look like this. Part A, right, part A, so we are considering only 0, right, 0, and here pi over 2 and pi, right? And here if it is 1, right, 1, the 4 we will mark it here, 4 we will mark it here, and if minus 1 is here, minus 4 we will mark here. So what would happen is the graph, I mean 4 dotted line we will draw, right, minus 4 also we will draw, and these dotted lines also we will draw, so we can see the graph, sketch the graph properly. So here minus pi over 2, right, and minus pi. So these ones also we can draw, and in black color I will put the 4 cosec x. 4 cosec x should look like this. So this part, right, this part reaching from here and going like this, and in this part, right, in this part reaching from here reaches minus 4 and goes like this, right. So he touches. So this is the actually y equal black color thing is the y equal 4 cosec x, right. So I use the stretching and I got the help of y over sin x, right, y over sin x. Now they are asking us to draw the same y equal x. Now here y equal x, right, y equal x. So roughly, right, now this is 4. Now if you take pi over 2, right, pi over 2, it is pi is 3.14. so if you divide it by 2, roughly 1 point something, right. So 1 point something, so we can mark here pi over 2 here, right, and minus pi over 2 are roughly here, right, minus pi over 2 roughly here, black color. So this is the coordinate where the x and the y coordinate is equal, right. Now if we take here pi, right, this is 3.14, so here it would be, now below this dotted line, below is 4 is 1, this is 4, but pi is 3.14, so this black color is there, so the pi equal x goes from here. And then another thing here, right, I think roughly we will mark this, straight line, right, straight line, right, roughly he will go like this. This is y equal x, so please in the Cartesian plane draw the x, and here pi also mark pi here, right, and show that it is smaller than 4, like that, okay, right. Here also minus pi is here, minus pi, because I'm drawing in this whiteboard, it is very difficult. Now here minus pi over 2 actually it should be halfway, so you adjust it and somehow show the sketch, but no need to be exact, this is also all right. Anyway, you are showing y equal x 4 coordinates, right, and now, right, so then we did that. So part B also we did on the same, and we should have the same range. Now the trouble is, now part C they are asking, right, now part C they are asking what are the solutions. So what are the solutions of, right, state, actually not the what are the solution, number of solutions, right, 4 cosec x, right, 4 cosec x minus x equals 0, minus x 0, right. So what are the solutions, what are the x values which will make LHS 0? Actually we have to take the help of this graph. 4, we can change this cosec x is equal to x, we can take to the x. So actually what we are doing is, if we want to solve this, actually we have to solve y equal 4 cosec x and y equal x. It's a substitution method. So if we want to take the simultaneous equations and find solutions, right, then we have to solve this a and b. So actually then when we are going to use y equal x, if we substitute here, we will get this. So surely we know from graphical method these two graphs are not going to intersect. Therefore, right, we can say therefore, since a and b graphs does not intersect, this we can say this one is capital X, right? Capital X does not have solutions. Does not have solutions. No, I mean no, if we cut, if it touches here, then one solution. If it cuts two, so if it's cut in two places, here also another two places, so four solutions. If it is touching here by symmetry, it should touch here also, then one, if one is a two solution. But if it is not cutting by symmetry, he is not cutting this side also, so no solution. So from graphical you can see the answer of the book also, they have done it properly. Example 4. Right, now the final example 5 I will do. Other things I'm going to do it on another day, right? Example 5 also I will do and stop. Right, actually now in example 5, page 51, we have to sketch y equal 1 plus sec 2 theta in the range of this, right? So what I have drawn is sec theta, right? Sec theta in the range of, right, in the range of 360, right? 360. So I mean that also we will see whether we have, whether I have drawn that correctly. Right now sec theta comes from cos theta, right? 1 over cos theta. So cos 0 is 1, then 1 over 1 is 1. Good. So when so like this, and cos 90 is 0, cos 90 is 0, and then it goes to infinity. Again it goes to here 0, and then it goes to infinity, right? Then again here 1, and he goes to 0, then 1 over 0 goes to minus, right? And again he goes to 1. So this shape is all right. Just see whether you are okay with that. Now interesting thing happens, right? This is sec theta, sec 2 theta. Please, I know there are students, right, who doesn't know the transformation. Now this is from, this is actually from grade 10 work, right? So what would happen when we have 2 theta here? It is the opposite behavior of y transformation. So if we have y equal fx, right, y equal fx, y equal f2x, right, f2x, what would happen for that is, if there is a graph, right, if there is a graph, right, like this, right, we'll say whatever, right, if we draw some graph, right, all the graph's x coordinates will go to half of it. It will stretch, because it is 2, it is not becoming twice. Now if you take y equal 2fx, then it stretches y-axis 2 times. Always these coordinates become 2 times. Whatever coordinates, y coordinate become 2 times. But when you have like this, inside x becomes 2x, actually it becomes half. And those explanations I have done, right? Again actually I can't do those, we have to see. Right now we'll see how we are going to stretch this into the this one. So here this shape, whatever he is reaching in 90, he is reaching infinity. So half of this, that should be 45. I will put in red, right? So what we should consider is this line, we have to consider this line comes here, so that means 45, right? 180, that line comes here, right? That comes line equal 180 divided by 2 is 90, and 270 divided by 2 is 135. Maybe he will come 135, 90, 70, maybe half of it, I don't know, right? Okay, so here 135, this will become 135. It's the, yeah, addition of these two exactly in the middle. This person will come here, and 360, if you divide by 2, he will come here. He will come here. Now if we follow the pattern, we can draw the others also. So actually we should consider another halfway mark here, red color, and another halfway mark here, right? So whatever now we have to draw it for the 3. I mean, I'm looking for this, right? To this one, +1 is actually shifting everything up, right? So 360 means we have to consider 720. So that 720 shape will come up to here, but we will start from this one, then we can see what's going to happen. So here the new shape would look like this, okay? And whatever this one, so yeah, so we did it like that. No, then after that we should have this negative fellow should come from here and should touch it here, right? So actually this part came up to here. So where will this part go? So shall I number, I mean, we'll say this is number 1, right? This is number 2, right? Now no need of numbering, but this whole thing, now this whole number 2 is actually, this is number 2. He comes here because half of it, 270 becomes half of it, so he should come here, right? And then after this fellow is there, so he should start from here, right, and should be right like this. So now you will see the pattern, right, how it is going to continue, right? So by looking at that, after that you can draw like this, right? He will touch the one, and here after that it should come from here. Actually he comes here. This shape is from another one, from this side, right? So this is how the shape will look like. Now all the coordinates are there, 45, 90, 135, 180, like that. Now what you have to do is shift all the fellows 1 unit up, that's all, right? So children, I'm not going to do that. If you actually shift 1 unit up, what would happen is, if you draw the x-axis from here, it will be the same. Shifting up means this all red color fellows, if you are going to shift up, that means this 1 unit, no, this is -1. So when it's going, he will touch the axis, this fellow will become 2, like that, right? So I mean, I will look at the answer of this one, whether I did it correctly, right? So you all also practice this by drawing that. Yes, it is like that. So the shape would look like this. So I can erase this part, right? Now I'm going to erase this, right? And I'm going to draw the x-axis from here, and I'm going to make this one 2 and here 0, right? So this would be the shape. So I mean, this black color things we can erase now. That was help, right? That was help. This was help, right? This was help. So actually the y equals 1 plus sec 2 theta will look like this. Here 2 units, and it is touching, and all the things you have to mark, right? Here pi over 2 will 9, no, here 45, right? 45, 90, 135, then another 45, then 180, then another 45, 220, 45 means 225, another 45, 270, right? Like that you mark, right? And see, so all the x coordinates are there, and y also the most important fellows are there, and here it should touch all the fellows, and also up to 360 we have considered here again 19, here 360. Between that you can put whatever, right? You mark this value also, right? So this is the shape of that, right? Now today I mean from this lesson we are finishing the 3 point what 3.2, right? 3.2 section theory part is over, right? 3.2 theory part is over. Now all the examples I did, but today I'm not going to do the difficult exercises. You all can attempt those on Tuesday, right? On Tuesday I'm going to release a I mean surely it's going to take, I mean I can do the lesson but uploading will be difficult. I'm going to release another one, so I will be doing the exercises of this, right? The difficult exercises of this. So now what you can do is again go through the examples and the theory part, and the most easiest ones you can attempt. I mean exercise this 3, right? Exercise related to exercise 3.2. Please finish it and keep. So Tuesday night I will release the some questions of that, and maybe 3.3 also I will touch. So here, right, I'll stop from here. I just want to see whether, yeah, example, yes. So exercise 3b, right? Exercise 3b, you all have to attempt some simple questions. Those are from page 52 and 53, pages 52 and 53, right? 52 and 53. I don't know whether you can see it, right? I'll stop from here.